So now I'll start with the RCBD. Okay, so RCBD or Randomized Complete Block Design. Okay, this assumes a single gradient running across the experimental unit. So ito yung nuisance factor na kailangan na i-consider natin, that single gradient, or we call it block. Okay, so the blocks, or the blocking factor, blocks are of equal size and each contains all the T treatments. Okay, so imagine that you have one block or a block having all the treatment levels there. So may presence ng lahat ng treatment levels. That's why it's called complete block. Okay? So complete block design. And then the experimental units within block are homogeneous. You expect that in one group or in one block, the conditions, for example, the variety or the type of soil, okay, homogeneous yung lahat. Under homogeneous condition yung experimental units. And then the variability among blocks is taken out of the experimental error. So because our goal is to minimize experimental error, okay, we need to consider a blocking factor so that, okay, yung pagkakaiba among blocks will be, okay, incorporated in that blocking factor na source of variation. Okay, basta the goal is to really minimize the experimental error by, yun nga, having this blocking factor. Okay, just to illustrate, so this is a picture of a single gradient, example, fertility gradient. So as you can see, say siguro the first row, less fertile siya compared dito sa last row. Okay, can you follow? Okay, so yun, nagdi-differ yung level ng fertility across rows. Okay, since if you have the idea nga ganon, so that's the situation of the experiment. So you have to consider blocks here, wherein you have block 1 having the same level of fertility, or for example, block 1 having a less fertile part, and then the block 3 with the most fertile part. So ito yon in the same block. Okay, and take note that block 1 has these 3 treatments, okay, present, and block 2 the same. The 3 treatments are all present, and then the block 3 also has these 3 treatments present. Okay, so now gradient is unidirectional. Okay, this one direction lang. Orient blocks such that they are perpendicular to the direction of the gradient. So if this is the direction of the gradient, so ganito yung blocks mo. And then use long and narrow blocks. So this is just a suggestion, no? Okay, to accommodate all the treatments. So we have long and narrow blocks. Okay. Oops. So we now have to consider this, no? Considerations in blocking. First, select source of variability as basis for blocking factor. So you really have the idea kung ano yung possible factor or nuisance factor, no? Okay, in the experiment. So that's your blocking variable. Then select the block shape and orientation. That's why yung kanina we have perpendicular in this shape, long and narrow. And then we have to consider grouping of these experimental units into blocks such that the variability within each block is minimized. Okay, yung discrepancies within the block is minimized. So halos pare-parehas lang yung condition. Okay, while the variability among blocks, okay, are maximized. So talagang nagdi-differ si block 1 sa block 2. For example, yung soil type na clay, nagdi-differ talaga siya sa loam, and so on. Okay, so we have this application. So usually yung mga applications ko is on these agricultural experiments, because basically yung experimental design actually was developed with this from this agricultural experiments. Okay, we can also apply this RCBD, to biological or medical experiments. So think of something, experiments na biological or medical. For example, you want to compare the, say, different dosages of drug, okay? And then, ano yung possible block could be in the experiment that can also affect dun sa mismong effectivity ng treatment. It could be the age, right? So your age can be your blocking factor. Then market research or in business. For example, you want to compare the different brands. You want to compare the different brands. Okay. And then, so yung price, siguro yung response variable. And then, yung blocks could be the different department stores or different malls. Okay? Yon. And then, sa engineering, industrial experiments, maybe you want to compare the different temperature, okay, different levels of temperature, and then your block would be the different brands of machine. Okay? So that's it. So those are some applications of using this RCBD. So randomization and layout. So we have this illustration. So let treatments T1, T2, T3, T4 be replicated 4 times respectively. Thus, the total number of experimental units needed is 16. So if you can imagine, we have 4 treatments, and then we have 4 replicates. Okay, so these 4 replicates are actually your 4 blocks. So one block, one replicate, having these 4 treatments, another block, another 4 treatments, another block, another 4 treatments, another block, another 4 treatments. All in all, we have 16. So that's 4 times 4. Now, we have to group these experimental units into 4 blocks. Okay, so we now do the grouping. Okay, dapat homogeneous, no? Kada block, okay? And then divide each block into T experimental units. Okay, so 1 block, 4 experimental units, since we have 4 treatments. So for each block, randomly, wait, cannot read, have to move. Randomly allocate the treatments into the experimental units at random. Okay, so take note that hindi lang siya bastang direct na ina-apply ng treatments. You really have to randomly assign these treatments to that block or to the certain block. Okay, so wait. Now we have this data presentation. So if you have this 4 replicates, so we have 1, 2, 3, 4 or 4 blocks, and then 4 treatments, 1, 2, 3, 4. So we have this. So 16 observations. And then we get the total and the mean.